Hello and welcome to another episode of Risky Business. Today is a little different. On the last episode, we were planning to boot up the Hi5 Unleashed, the risc-v PC to Fedora. That was the goal. But the show went on hiatus for a while. I was going to do an update, but I haven't managed to, find the time to really make a nice update video about what's been going on. But basically, the short version is, it's financial. Until I'm, have a more stable financial situation, I can't really be, doing this right now. However, Handmade Seattle is coming up, and this episode here is being recorded offline because it hasn't been publicly announced that I have a booth at Handmade Seattle, but I do in fact have a booth at Handmade Seattle, so I'm going to be there, and I'm hoping to show off the risc-v PC. So I need to prepare for that. So, this month coming up to it here is I'm just going to focus on getting something ready for that. So, yeah, I got a booth, but, I actually need something to demo. So, little details to work out. Just little details that need to be worked out here. But yeah, I'm hoping to do the risc-v PC here for that, and so we need to get it booted. Of course, we need to get it to actually boot into Fedora or whatever else, something that we can actually demo, and then hopefully we can get a case done in time too. It's gonna be a trick to get that done in time, but I'm gonna attempt to anyway. I'm thinking, rather than going with what we were originally planning, we're just gonna do a really fast, simple 3D printed, enclosure. Hopefully we can do some kind of clear or transparent acrylic type of, case, sort of like a glass see-through enclosure type of thing. With the bottom just being, like a solid black plastic or something like that. And then hopefully in the future we can, replace this with something a little nicer. But, just to have something, rather than just, taking these components here, and just, dumping them in a suitcase and, maybe wrapping clothes around them or something. I have a feeling that would not end well. We might end up with some broken hardware, maybe some ESD, or just from bumping around, they probably get damaged. It would be a good idea to have a case for this thing. I think that's kind of important. Plus, for the demo, it would be nice if we actually have this thing in an enclosure of some kind. So I want to do that right now before I do the actually getting the thing to run, because it's going to need to be manufactured and shipped to me, and we're going to want to make sure that the design it actually works. If it doesn't, we might have to do another iteration, and so it's going to be a trick to to get this done in time. There's not a lot of time, but hopefully we can get it done. That's the goal. So that's why I have this, this whole setup that you see here is for doing that work. And you can see up there, we have OpenSCAD set up. I reinstalled Arch Linux without wiping everything. I just did a fresh install over what we have rather than running updates, because on this machine, it's been over a year since I've done updates on it, and I know that running updates, it's just going to break a whole bunch of stuff and it's going to take forever to sort it out. So I just figured it'll be faster to do a fresh reinstall. And when you do a fresh reinstall of Arch Linux, you don't have to wipe your partition. You can just reinstall on top of what you've got, you know, just delete your system files and leave your home directory and your etc directory and stuff like that, and then just, you know, run a pack strap again. And so that's what I did, and got this set up again. So we're you know, a more up-to-date system. Hopefully the recording turns out good. I don't know with the new OBS and everything how that's gonna go. But hopefully the video will be good. If not, we'll get it sorted out by the next one. Now, before we dive into designing a case, I want to give some shout outs to patrons right away. And well, I should say, you know, it's been, the plan was that I'd be back after the trip to the Philippines in January. The trip was in December, and I'd be back in January, and then I'd continue the series. But you know, plans changed, and if you want to, you know, stay up to date with what else is going on with me, the show has been on hiatus, and I tweet all that stuff on my Twitter, so that's at HMN_risky on Twitter, or you can just go to twitter.risky.tv, and you know, that'll take you there too. Those both go to the same thing, this Twitter account right here. And so I've been keeping that up to date with what else going on, but I haven't posted anything on Patreon. So the transparency reports and you know, the blog updates and stuff like that, I will get back to that, and I will cover the entire time period that I've been on hiatus. Like, there are going to be transparency reports for that time period and everything. It's just not a priority right now. You know, it'll be back when I have you know, more work lined up and I'm more financially stable, things like that. But yeah, I want to take some time to do some Patreon shout outs right away, rather than at the end. Like, I usually do them at the end of the episode, but I want to, you know, start with this because you know, it's been a while. It's October now rather than January, so it's been on, you know, the show has been on hiatus for a while, and I really appreciate everyone who has you know, supported me through that time period while the show is on hiatus. That money goes to, you know, Miblo, of course, to run the guide.risky.tv website, which let's actually take a moment here to show that off. I haven't ever shown this off. I've talked about it, but I haven't really shown it. I want to just show it quickly. Okay, so here's guide.risky.tv. I guess I should switch scenes just a second. Okay, so this scene is a little bit broken right now because of the updates and stuff. This is the usual risky business scene. Let's just close some of this stuff. This one. Okay, there we go. That's good enough for now. So here you see this website. It's set up now that you don't need like a secret link. You just go to guide.risky.tv, and if you support me on Patreon, you can get access to this, you know, the inner sanctum of this website here. So it's pretty nice if you just sign in with Patreon. I'll just say, yeah, allow that. So you get this page now when you're signed in, and you see you can select any of the playlists. Basically, you've got the main risky business, you've got the book clubs, Coad, and risc-v reader, and then the miscellaneous stuff, the riscalaneous. And if you click on one of these, you get the episode guide, and you can see here it's the typical episode guide. And you can query stuff like, I don't know, PWM, you know, and see all that in real time, and, you know, go and play an episode and stuff like this. You know, the whole shebang,
So
basically.
I think at this point we need.
So pretty nice stuff there, you know, and it's nice because if you compare it to, well, maybe they've improved this now, I don't know. But if you go to sonera.risky.tv, which is the publicly available one, okay, yeah, they have improved it a bit. So the riscolaneous is just called Risk here, which is, you know, it's just called Risk for the miscellaneous ones, but it's riscolaneous, and that's, you know, if you go here, it's this one right here, riscolaneous. And, you know, and then it used to be that they had Coad and the reader ones as a single thing, but now they've managed to actually split it up, which is nice. So they have improved that since I last looked at it. You know, it's just kind of nice to have this site here, and it's got, you know, nice theming. Miblo did an amazing job. I mean, he put this whole website together. He made the logo for us, which, you know, I wasn't expecting that at all. That was like above and beyond that he made a logo for the series, you know. And these are like, I looked into this recently too, and these fonts are like paid paid fonts. I believe he actually, you know, has paid to like license and use these nice fonts here, and, you know, it's just a nice design for the site. And this is not just it's not just the same thing as this, because this is public. It's only, you only get access to this, like videos on here, when the videos go public. But the videos are available before they go public to patrons. And as soon as Miblo gets them annotated, they go up on this site. So if you need, you know, to use the annotations, or you want to use the episode guide, you actually get early access to that if you support me on Patreon by using this website. And in the future, I want to have it so that $5 and up patrons have access to the downloads that I provide for software that's exclusive to my patrons. I want to have like a download page for them on here at some point too. But yeah, Miblo has done all this work. It's absolutely amazing. So I'm very, very happy that he's made this stuff. You know, it's really, really great. And yeah, I'm just very, very impressed and happy with this little guide.risky.tv here. And that's one benefit that you get if you support me on Patreon. And of course, you know, there's hosting costs associated with that, and so all the money I'm making on, you know, Patreon is just going to Miblo to keep this sort of thing going, you know. So yeah, even though the show is on hiatus, you know, money is still being spent to keep things like this going, and so support is greatly appreciated, even though I'm not producing content right now. And that is why I want to take a moment here. Let me switch back to the other. Are my webcams not going to come back on me here now? The webcams are very finicky, I find, with OBS. I might need to stop recording and restart OBS here to get the webcams back. Hold on. Okay, we've got the webcams back. So what I was saying is, yeah, it's greatly appreciated, any support that's given during this time, because obviously, you know, it's a harder sell to to support the series when it's on hiatus. But you know, money is still being spent, and it is still, you know, needed. And I want to give shout outs to people who have like new patrons that have contributed during this time period. So, of course, we've lost plenty of patrons, which is fine, you know. no one has to support the series, especially when it's on hiatus. I totally understand that. But yeah, I want to give a shout out to Jose Hernandez Sanchez Lugo. He supported some during this time period. And Peigia, I don't know how you pronounce that, P-E-I and then J-I-A. But yeah, these people supported within this time period that the show has been on hiatus, as well as, you know, all the people that are still currently supporting me, which I won't, you know, reiterate their names, but you know who you are. So yeah, thank you everyone who's continuing their support or who has contributed some support over the period that it's been in hiatus. I can't stress enough how much I appreciate that. That really means a lot. So with that said, let's get into actually doing some work here. So I'm familiar with CAD programs. I've done a fair bit of that stuff. Okay, here's Milton. I've done a fair bit of CAD stuff in high school. I had a class, and it was like the whole like designing products, bringing them to market, marketing them, you know, user feedback, talking to people. Would you like this product? Would you buy this product? What would you want in this product? You know, would you do something differently with this product? Yeah, things like that. And then, you know, iterating on a design, doing presentations to try to get, you know, like investors and things like that. It was like a course that was all about that type of thing. A very practical kind of, you know, aimed at people going into like an engineering sort of field. And a lot of it, like I'd say the vast majority of what we did in that class was designing stuff in a CAD program. I believe it was Autodesk Inventor that we used in that class. And yeah, we studied it in depth, did a lot of stuff with that. And yeah, a lot of designing things, both you know, following along with steps, and then also like, okay, now you're going to design your own thing using what you've learned and stuff like that. And so I'm pretty familiar with that, and I've done other ones as well. I think SketchUp a little bit, and I think there was one other one too that I used in another class a little bit, not very much, just a little bit. But I don't, you know, it's been a long time. I don't know how much of that stuff I remember, but I am familiar with the more traditional kind of CAD programs, and there's like FreeCAD, which would be more like that, I think. But I was looking into what we could use to do CAD for this project here. And of course, that was kind of what I was thinking we'd be going with, something like that. But then I discovered OpenSCAD, which you see here I have like, I know it's small, it's just this up here instead of the big screen over here. It's the little one up there. But so basically here we have NeoVim open, and we can type code in here. And this is just basically like a 3D renderer that will watch your file. And when you update your source code, it updates the render. So right here I've just typed, you know, cube 16 is the dimensions for it, and centered equals true, right? And you see you've got a cube there. You know, we could do sphere 42, and there's a big sphere, you know. So this is kind of what we're working with here, right? And so here, where is a good default view for us? Well, whatever, let's just... Yeah, that's pretty good. Okay, so this is what we're working with here. And yeah, we're going to try to design a case in this. And I think it'll be fun to use this because, you know, as a programmer, how can I resist, right? to do it in code instead of a more traditional thing. Even though I'm, you know, I'd be more familiar, excuse me, with something like FreeCAD. I think this will be a lot of fun. So I want to give this a try. I don't like the language though. I'm not really a fan of how they've structured the language. It's like a bunch of parentheses, or not parentheses, curly brackets basically. And if it were me, I would have designed it like in D you have the kind of functional style where you can chain things together, like function application as like an operator. Basically, it's universal function call syntax is what they call it in D, where basically you can pretend like a function is a method where the first argument, you know, is like you put it as it's like you just write it and then you put a dot and then you put the function and then the rest of the arguments passed to the function. And it's like it makes it look like it's a, if you're used to like C++, it makes it look like it's a, you're calling a member on an object. And so you can chain those together. So you can just have a bunch of functions and then, you know, kind of put together a pipeline. It's like in Bash or something where you have a Unix pipeline and you just pipe a bunch of stuff together to transform data through a pipeline. That's kind of how I would design something like this, but that's not how they do it. And I think their approach is kind of messier, but it doesn't really matter, you know, it's just syntax. But yeah, we're gonna have some fun with this, I think. So to start with, we need to measure stuff. And in Milton here, I refreshed myself on the last episodes, and yeah, so we measured the height of like how far up we're going to need to make the case go to match with the High Five Unleashed, because it's raised up from the expansion board. So we're going to look into that. Here, let me get a ruler quick. I've got my calipers here, but I'll get a ruler to do some of the, you know, some of the larger measurements here, like, you know, this whole distance and things like that. Just a second. Okay, I've got a ruler. I'll put on my ESD strap and let's start measuring things. Oh, and the other thing is we have an anti-static mat down here. Now, rather than using the plastic bags, we learned that the outside is not anti-static, just the inside of the bags. So we're going to be using the anti-static mat instead. That's definitely a better way to go. Okay, so first off, let's just focus on this board here. So okay, let's measure this in centimeters. Okay, that looks like about just kind of eyeballing it here, but I think it's around 27 point 1 or 2. 27.2, I think. We're gonna go with 27.2. Here, let's maybe let's put this in our code. So we're gonna say expansion board. I'll just call that EB or EXB width equals 27 0.2, although we want that in millimeters. That's 272 millimeters, right? Yeah, 272. Just double checking my math there. So, and the way this works basically, I know you can't see it well because it's on the little thing here, but I'm just typing in, you know, the expansion board width is equal to 272, and it's unitless. It's a unitless thing, and apparently 3D printers are unitless too, from what I understand, but basically we're going to treat this as millimeters, I believe, and that's like the default or something, is the unit is millimeters from what I understand. So now, oh, and I should say I put a link for myself up on Twitter. Yeah, note to self here. So there's this post from Formlabs, how to design 3D printed snap fit enclosures. I'm thinking we're gonna go with something like that, and it looks kind of like what I was thinking. I was thinking, you know, to get used to the CAD program we're going to use, we should, you know, do a very rough design of the board. And then once we do that, we'll design the case to go around the board. And that's what they recommend doing here too, actually. So you can see in their step 1, prepare your custom enclosure design. They actually started by doing a rough model of the board that they're working with here. I don't know what this you know, what this project is that they're doing here. I didn't look into it at all, but yeah, they just did like a rough model of the board, and then after they did that, they did a bottom enclosure, you know, and then here you see they've, you know, made spaces for the you know, cutouts for the expansion like ports and stuff, and then they do a top that sits on top of that, and then they show how they did the snap to lock the top in place. And I'm thinking that's what we're gonna do. Basically, I want to have like a clear top and then like a tiny like opaque, probably black plastic bottom, right? And then it's gonna, like, the top of it is gonna be like this clear acrylic, or, you know, see-through, something transparent, like a glass type of thing, but presumably like a 3D printed plastic. I imagine something like that. And it's going to have this same kind of mechanism. And then it's just going to, you know, snap into the bottom is kind of what I'm thinking. So yeah, it'll be something like this. And then they show doing these lugs or whatever. And then they did some final detailing here. So this is the end result of what they produced here. We're going to be doing something like that, but not nearly as fancy. You know, we'll go with something more like this, but even this is fancier than what we're going with here. We just need to do something fast, something that'll do the job and is fast to produce. That's kind of what we need here. So yeah, so we've got the width at 272 millimeters, and let me see about the height here, or I guess not the height, the depth. Well, maybe nah. 11.8 maybe? 11.7? Let's go with 11.7, so 117 millimeters. I'm going to call that EXP depth equals 117 millimeters. Now, if we do like a square, I think if I say 272, or let's say EXP width EXP height center equals true. Let's see what that does. Not height, depth. Okay, yeah, so here you can see we've got a flat surface, and it gives it everything like a 1 millimeter depth to it, but that's not actually there. Like this is just like a flat surface. It doesn't actually have any height to it. That's just how it renders it. So if we want to, you know, actually make it thick, we need to actually extrude it. That's something to keep in mind. But yeah, this is the basic shape we've got here. So let's work with that. So here, let me. Okay, there's a good dead-on view of it. Now, the thing we need to be concerned with is where these standoffs are on the bottom of it. And I suppose let's just design it as being extruded down as far as these standoffs go. So let's see how far down is that. So I'll break out the calipers for this measurement. Okay. Uh-oh, is it dead? We might need fresh batteries here. It's not dead, but the screen is very, very dim. Like practically dead. I think there were extra batteries though. Let me take a look here. Okay. It just uses one little button battery. Okay, now where would I have put the extra battery? I think I must have put it in here. Indeed I did. Okay, let's see if this battery's got a little more juice in it. Oh yeah, it does. See if we can't. There we go. Okay, there we go. Now let's zero it. Now, I am just going to well, first of all, let's do the board thickness. .3. I think 2. We tighten it up there. It's like 2 and maybe some change. 2.0 something. Let's see if we can do this at a better angle. Yeah, I think it's 2 millimeters. We're just gonna call it 2. You know, it varies depending on how much we squeeze it. But we're gonna call it 2 millimeters. So I think the way you do this is you just say linear extrude for 2 millimeters, and then we use curly brackets around the thing we're extruding. Something like that. So did that really extrude it? Let's comment it out, save it. What didn't it like there? Oh. Okay, so this is the original. That's the extruded, yeah. So there it is, extruded. Now, we're going to do the bottom of the board. And, oh, and I should say while I'm at it, right now I'm holding together the SSD, the NVMe SSD. I'm just using one of these standoffs. One of these extra standoffs is what's holding this thing in place here. I don't know if you can really see that, but right here, see that? Just a standoff, right? But I learned recently. So we had included with the expansion board, we had a mystery item, and I didn't know what it was, right? I showed this in the unboxing video, I believe it was. And I was like, I don't know what this thing is. It kind of looks like a little card, like a, you know, almost like an SD card, but it has like a nub sticking out of it. Yeah, this is the like the thing to hold the like the standoff to hold the SSD in place, apparently. So yeah, I didn't realize that. So yeah, we have a screw, an O-ring, and this little guy here that were included. And I didn't understand what that was, but I looked at the, let me open this up for you guys. Here, let's just fire up Chromium, and we are going to search, what do we want to search here? High-5 Unleashed. Unleashed. Expansion board. So here's the crowd supply for it. Let's go to their product page. Okay, so if you look carefully in their documentation, I don't know if this was originally available. I thought they didn't have documentation on the expansion board, but they do now, at least. If you look carefully here, High-5 Unleashed expansion kit quick start guide, and then there's schematics. And so I was looking at the schematics file. So if you look through the schematics, it's a bunch of schematics, but keep going and you get down to here. There's a page on mechanicals, right? And they talk about, okay, screws for board standoffs for the board, and it talks about standoff and screws for the board again here. And then look at this, M.2.5 standoff and screws for M.2 SSD. Bag and take. And I'm like, oh, I was like, I don't think mine came with this stuff, did it? So it's supposed to have a screw and a little washer here, and a standoff for the SSD. And yeah, I didn't think mine came with this, because if you look at it, if you look at the diagram here, it certainly doesn't look like what I just showed you, right? Like, this is the diagram of the standoff. And so what I did is, if you look at these part numbers, there's like these codes for the part number that's listed under each diagram. And so if you just copy that and search for it in Google, you can find these parts, right? And you can at least get equivalent parts if you know what the thing is. If you look up the part number and then you find a part sheet on it, it'll tell you the specs of what you're looking at. And so you can either buy it from whoever if they sell it, or you can take the specs of the thing you're looking at and put those into Google and find an equivalent part. And so I did a little bit of shopping, and I got some equivalent parts here. So you can see I got the equivalent washers, although these are metal, which is probably not a good idea. And then I got some screws. I believe these are like plastic, probably 3D printed. And then when I got this in the mail, this is when it dawned on me, because here we have the standoff, and like I say, I think I maybe even ordered this one from DigiKey themselves. I don't remember which parts I ordered where, but yeah, I ordered one of these, and I was expecting it to look something like this, something like this. But what they actually send you when you get the part in is, if I take it out of the bag here, look at that. Does this look familiar to you? That same little card form factor is what we have here. So that actually is the standoff in question. It just has this, plastic remaining from, I guess, the print process or what have you surrounding it. I suppose that's useful for holding the SSD in place, that extra plastic. I don't know. But anyway, this is the part we're actually looking for here. And so yeah, once I saw this, I realized, oh, we did actually already have this stuff. I just didn't know what I was looking at. I didn't know what this actually was until now. So we figured that mystery out. Yeah, so we can replace this kind of hacky setup I have to hold my SSD in place with something a little bit more proper now, which will be nice. But yeah, so if we look at the board here, Let me move some of this stuff aside. So the next thing to do would be to, mark off all the standoffs and everything. I think what we're going to do is we're just going to linear extrude the model to cover the region with the standoff. And then, yeah, after we do that, we'll need to pinpoint each of the locations of these, each of these locations of the standoffs here. And, then we'll need to cut out some regions to mark those off from the model. And we'll use that when we design the case to line up where the where the holes should go, so that we can have the standoff sit in those areas, and then we can screw the case onto or screw the hardware onto the case, I should say. So let's start by measuring how far down the standoffs sit compared to the bottom of the board. Okay, so let me take my board here again, and I'm going to 0 my calipers, open her up. I suppose I should do this slowly, right? I just remembered to get more accurate measurements that way. 0. Well, I suppose it'll be the height of the standoffs, right? So we're looking at, well, if we go up to meet the top of the board, I'll add an extra 2 millimeters. That'll let us get a good sense. Yeah. So 19.5 is what I've measured there. So if we subtract the extra 2, that gives us like 17, a height of like 17. 17.5, something in that ballpark. Okay, and we had calculated something here. What was this again? 17.98. I think that was the height to the height of the High Five Unleashed, like from the ground level to where the High Five Unleashed sits. 15 millimeter standoffs. Now, are we talking about the High Five Unleashed standoffs there? Or are we talking about the standoffs? Yeah, we're talking about the High Five Unleashed standoffs, that 15 millimeter. If we look at our specs for the board, We should be able to figure it out, right? So they detail a whole bunch of these here. Are these all the same part though? I think these are all the same part. Yeah, these are all the same part, this standoff. So this must be our standoff. This will be a good opportunity to see how good we're doing with our measurements here. Because we should be able to get the accurate measurement of this standoff by looking up the part number. 18 millimeter. Okay, yeah, we measured it to be like 17.5 and it's 18. So that was about, you know, half a millimeter of error with our calipers. And I mean, I measured to the top of the board to the bottom of the standoff, and then I, you know, subtracted 2 because I know the board is like 2 millimeters thick. So that's how I came to the 17.5. And, you know, I'm being a little loose with my measurements, so I'd say half a millimeter of error with that procedure of measurement is pretty reasonable, right? But yeah, so they're 18 millimeter. So we're going to extrude an extra 18 millimeters going down here. So let me look at my model again. Where did I have that? Here it is. Okay, so let me add some more variables. exp height equals 2, standoff equals 18, right? And then I'm just going to say, let's linear extrude by the exp height, the expansion board height, plus the exp standoffs. So that's just going to give us a solid rectangle, you know, which is a very rough model. Of course, this is not like a super accurate model or anything, but it will do for our purposes. I wonder if I can do it in 2 extrudes though, so that we can see the part that's the standoff and the part that's the board height. Let me just play around with that. So we're going to do 1 extrude by the height, and then we're going to do another extrude by the standoffs, and that should give us the same thing, right? Maybe not. So that didn't work. You can't stack linear extrudes, I guess. So like there's that. If I comment this one out, there's that, but we can't do them together. So I guess what we need to do is we need to duplicate our square. But then translate it down by the height of the Now, I don't know how the translate works. I'm gonna try so translate 0, 0, negative exp height. I think that would do what I want. Okay, now if there are these like debug symbols in OpenSCAD. So we can disable with an asterisk. We can do show only with an exclamation mark. We can highlight with a hashtag, a pound symbol. And we can do transparent / background with a % symbol. So let's do the highlight. Let's highlight these lines here that we just did. Syntax error. Okay, so I guess you don't put it on every line. Okay, interesting. So it seems like you just put it on the translate or the linear extrude. Seems like either one does the same thing. Okay, so interesting. Okay, let's so yeah, I don't totally understand what's going on here, how this highlighting, what it means. Okay, so I don't think my translate did what I was hoping it would do, right? Because like, if I take this out, this is what we have. Okay, so this thing is actually higher up. Okay, so I think I went the wrong direction is what that's telling me. That makes sense now that you think about it, what this was showing us, right? What it's showing us is all of this is highlighted. This slice we see in the middle here, right? This is where it overlaps with the top, with the board itself, right? And then this region above it is, you know, sticking out above because we went the wrong direction. That's what that's trying to tell us, right? So if I take away the negative sign, see, that's what I was expecting, right? So I've highlighted the standoff region, right? That's the red region you see here. And then you see the the yellow region above it, that's our board, right? So this is doing what I wanted, right? So rather than marking off the actual standoffs, I've just just filled that region in, because we don't need a detailed model of the High Five Unleashed. We just want to get a rough, a very rough model, so that we can, something we can work with. It doesn't need to be detailed. It just needs to be something that we can say, okay, here's where the pieces we care about are. Here's the rough dimensions of the hardware we're working with, so we can build a case around it. Okay, so the other thing we're going to need to add to this model is the place where the screws go. So we're going to want to put that on the underside of it. This region over here, right? So this area is where we're going to want to put. I'm going to want to put screws. So I need to mark those regions off, and I think we're just going to mark them off with like some circles. So we can figure out the outer and the inner diameter by looking at the part sheet again, I imagine. Yeah. Okay, they don't mark off the inner diameter, but the outside diameter is 2.17 inch, 5.5 millimeter. So they're a 5.5 millimeter, but they're hex. They're hexagonal. So it's not actually a circle; it's a hexagon. So when we talk diameter for a hexagon, I don't know what the normal lingo is here. Are we talking like the corners, like from corner to corner? Or are we talking like side to side? Let's just try measuring the one we have on top here. Or actually we should do one on bottom, just to be sure. So I'm just going to see if I can get a rough feel for what the diameter of these things are. We'll probably just model them with circles, because I mean, we just need to make circles on our case so that we have something that we can screw, just a region that we can put a screw, basically. Okay, let me reset the calipers. Okay. So I'm going to do side to side. .84, 5.85, somewhere in that region. So yeah, I'm getting like 5.8 to 6-ish, from one side to another, which is larger than I expected. So I wonder, when they say a 5.5 outer diameter, it could just be measurement error on my end that I'm getting a slightly larger number than that. You know, it's not like my measurements are perfect. Or it could be that they're talking about the diameter of like a circle within the hexagon. So like if you imagine the hexagon as a polygon and then you sweep a circle that fits inside the polygon, inside the hexagon, you have a circle, right? I think that circle is what they're talking about, that's 5.5. If you were to fit a circle inside of the hexagon, like the largest circle you could get within the hexagon, I think they're saying that that would be 5.5 millimeters. I think that's what they're saying in terms of diameter. So now, when we do a circle, okay, so you can specify by radius or by diameter. Let me zoom in so we can read this easier. Yeah, so see, you can say circle and then you can say d equals and give it the diameter. So okay, and I believe to say only you do an exclamation point, right? So let's just say circle d equals 5.5. Yeah, so there's our circle. And it's oh, okay, if you do the full render, it shows you that it's flat. That's nice. It looks very polygonal because of the way this thing works, basically. So if I change that, they have like a variable for how detailed you want the render to be, and so you can increase the polygons to make a more, you know, a nicer approximation. So I don't know what the default is. What's the syntax for this? I think it's called FM. That doesn't look any more detailed to me. I know there's a thing for this. Oh, is it FN, number of fragments? Yeah, that's what I'm thinking of. Oh yeah. See there, if I set that to a larger number, you see it's a circle, right? So if I lower that to like 50, you see it gets a little choppier. If I lower it to like 5, you know, you see, so there's 5 fragments and you see it's a pentagon. That's the closest approximation it can do with 5 different segments, right? So you increase the number of segments, you know, here it's approximating a circle with 50 fragments, but that's not relevant to printing it. It's purely relevant to the rendering that we see on our screen, because you know, if you make that number super high, you get a very accurate view, but it comes out at the price of, you know, a lot of time spent rendering, right? Like the performance, it's a performance optimization from what I understand. So yeah, but let's try 100 because it looked pretty nice at 100. And then if that becomes an issue performance wise, we'll just lower it, you know. not a big deal. It's just a, just like a debugging type of thing while you make your model. It's not important. So anyway, here's the circle. Now, I'm gonna want to have a bunch of these, so we're gonna need to make like a list of coordinates for each one of them, and then we're gonna like loop over the list and place a circle, and we're gonna want to translate them all down to be in line with the bottom of the standoff region. So basically, what we're going to do is we're going to say translate 0, 0, exp, which is expansion board height plus exp standoffs, which is how high the standoffs are. And give it some curly braces. Why did that not move? What did I do wrong here? Oh, okay, it's just because I was showing the circle, not the translated circle. So there you see the translated circle is, down here. If you zoom in, you can see where it is, sitting at like, 18 or whatever below the origin. And if we choose to highlight it, now we look at the bottom of the board. So let me zoom out a bunch, flip it, zoom back in. Yeah, so there you see here, let me see, can we get a better side angle? So is that sticking out of the board, or is it? I think it's embedded into the board, right? Or is it sticking out? Here, let's do one of those like side views. Oh no, it is sticking out. See that? I mean, it's not actually, because it's just how it renders it. But yeah, let's maybe I'm just thinking, how do I want to, like, maybe we want to just say like -1. So now it's inside of the, so if I make this transparent, Okay, but why do I not see? Why do I not see my circle here? Should be highlighted. Okay, well, if I have the so there you can see it, right? And then if I were to do like difference of these, it should like cut that out, I think. Or is that not how that works? Oh, I suppose because it actually needs to have some depth to it, right? Not that we need it to have depth to it, but so let's just do a linear extrude by 1 millimeter. Oh, but then maybe take off the -1. Yeah. So there you see you've like cut a little hole, I think. It's hard to tell. If we've actually cut anything though. So like okay, that cuts. I believe there we've cut. Yeah, see, there's a hole, right? So there you can see it cutting through. This is the actual region we're cutting, right? So basically, if you just want to cut out one little, a 1 millimeter circle, what I figured out here is I can translate it down out the way, and then just back it up by 1 and then say linear extrude it by 2. And what that ultimately does is it creates a circle that's extruded up like this, right? And then when you do the difference of that and the standoffs, you get this little cutout here. So that's useful for kind of learning how this program works, but we don't really need those cut out in this model. This is just we just need the circles marked off for what we're doing right now. But we'll leave it like that. So now we just need to figure out, well, first of all, how many circles do we need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Looks like we're going to need 15 standoffs, or 15 screws for our standoffs, basically. Okay. Now, how do we do that? How do we make like an array of So let's take a look at their for loops. So we're going to make a vector and then iterate over the vector, I take it. Okay, it looks like you just do, nested braces for this kind of thing. Yeah. So here you see an example iterating over a vector of vectors. And yeah, they just have like the X, Y, and Z for each one. Okay, I think we can do something like that. So we're gonna say like standoff points, I guess. So we're going to specify them from the origin, and we're going to say equals, and then it's just going to be 15 vectors. Okay, and now we're going to need to fill out where these actually are. Now, do we have a good diagram of this already online? Or are we going to have to figure it out ourselves? So, not in the schematics. Here's a nice picture of the board layout showing where they are, but it doesn't have, dimensions. It doesn't say where exactly these are. I don't know if it's to scale. I imagine it is, but we might want to just measure it ourselves. Let's check the quick start guide for it, see if that has anything to say on the matter. Yeah, no, there's not too much information in this quick start guide. Okay, so we're just going to figure it out ourselves where these points are. Okay. So let's see what we can do here. I think we're looking at about 4 millimeters. Let me double check with my ruler. That might be a good option here. Yeah, I think this one's like 4 millimeters from the edge of the board. In both directions. Okay. So let's say we're looking at it like this. So for you guys, we're going to look at the board sort of from this direction. This is how we're going to model it. We're going to say it's in this orientation. Okay. So then the one I just measured was this one up here. So that's going to be the bottom left. Okay. So, bottom left. I guess it doesn't really matter which order I put them in the array, but in terms of how we translate it, let's see here. So we're going to need to go to the left from the origin and down from the origin, right? So negative in both directions. And it's going to be like negative exp width -4 or +4? +4, right? Moving back towards the origin. And then negative exp depth +4 and I just need 2 elements, I guess, because the diameter is going to be the same for all of them. So first of all, let me comment out this array that I'm making. And then let's just try those dimensions on the circle we already made and make sure that looks good. So negative exp width +4. I wonder if I should switch these scenes in OBS so that you guys can see this as like the main thing, because I'm doing this modeling more than I'm messing with the hardware right now. I don't know if I really want to mess with OBS right now though. So you'll just have to live with it for now. Next episode I'll do that. Okay, so negative exp width +4. Negative exp depth +4. And I do not see it anymore. That's not a good sign. Where did it go? Well, let's say only show me it. Problem is it's so small. Oh, there it is. It's way out here. What are you doing way out here, guy? That's way off. Why is it so far off? It can't be the +4 that's getting it that far off, right? Here, let me reorient this. Right. So I want it down here. So yeah, it's going in the right direction at least, but it's way off. Why is that? Yeah, no, the pluses are correct. Oh, because this the board is centered around the origin, so we want half the width, half the height, or half the depth. This divided by 2, this divided by 2. Okay, that's looking like it might actually be reasonable. Hey, there we go. See that? That's looking more correct. Wait a minute though. My z-axis is pointing up, and this is the top. Why is it on the top? I thought it was supposed to be on the bottom. Why am I upside down? Okay, let me get oriented here. So I may have designed this upside down. Let me see here. So this guy, yeah, I designed this upside down. Well, we can fix that. Did that work? I don't think so. Oh, the extrusion needs to be negative also. Or does that not make sense? It just disappears when the extrusions are negative. But don't they have to be negative? I'm a little bit confused. Let me take a look at the linear extrude thing. Where is that? Height, center, convexity, twist, slices. Oh, that's good to know. It's always performed from the XY plane to the height indicated along the Z axis. So if you rotate or apply other transformations before extrusion, the extrusion is applied to the projection of the 2D polygon to the XY plane. Height must be positive. Oh, okay. So I guess what they want you to do is translate it down and then extrude up rather than the other way around. I guess we should just move it up so that the bottom of the board is at 0, at 0 on the x-axis. The bottom should sit on the x-axis, and then we'll just extrude up from there. So I kind of designed it backwards, and it doesn't seem to be made for that. Doesn't seem to be made to do it that way. Maybe there's other, there's probably other ways to do it if you wanted to do it this way, but I don't know. So in that case, let's redo this. So let me comment all that stuff out. Now, our board, we're going to need to translate up. So here's our board. And then we're going to translate that up by exb height plus, or no, I guess we just translate it up by the standoff's height. Right. And then we're just going to not translate the standoffs. Yeah. Like that. So now we see if we highlight. So that's correct, right? Looks good to me. Okay. And then we're going to cut out our circle from the bottom here. That looks like it's approximately the right place, but I don't see it as being cut out. Okay, so the depth I think we just want it to be like 1 up, right? 1 up from 0, because 0 is the x-axis. So I've got a syntax error. What's my syntax error here? Aha. Still have a syntax error. What is my syntax error? Oh, one extra set of... Okay. Now, where are we? Seems like we're in about the right place. Oh, okay, there we go. So if we put it at -1, yeah, if we put it at -1, we say go 2, there we get our, okay. So now we have our spot marked off again, and we are correct with our coordinates now. So you can see, you know, this here is the top of the board, and then the bottom of the board is what I just highlighted, this region here. You know, and that's like the region where the standoffs are, and then the little cutout is where one of the actual places you would put a screw. You know, we are making progress, and you know, like this is the first time I've ever used this program. I'm not like familiar with the language. I just kind of looked at it a little bit. So I think we're doing pretty good for what we're working with here. So this is just like an example that we've done here. Now we need to figure out where all of them are. So that's just 1. Okay, and then we need to correct this one up here. That needs to be divided by 2. That needs to be divided by 2. Okay, and with that, we're good when it comes to standoff points. So now let's see if we can't turn this into a for loop. Right now it just has one element, but we're going to try to do the loop. See if we can get that working. So we're going to say like for P equals standoff points. Let's look up the syntax because I have no idea what the syntax is for this. Yeah, for variable equals vector. I'd like to see an example where they use a variable, but they maybe don't have such an example. But I'm thinking our syntax should be more or less right. Let me see. Okay, so I think what we do is we say for P equals standoff points, do the stuff you were already doing, or wait. I want to do this inside the difference. Okay, so for P equals standoff points, we're going to translate, and then, so for the first argument, the X argument, I'm going to say P0, and then for the second one, I'm going to say P1. And for the third one, it's just going to be -1, right? For all of them. And then for all of them, we linear extrude and put a circle. Okay, did that work? I think that actually worked. So let's just put in another one. You know, without measuring, we're just going to put in an example. Let's just say like 0, 0, the origin, right? Yeah, that works. So there you can see I can easily put in as many circles as I want by just looping over a list of points. So now we just need to figure out where all of them need to go, basically. So again, making very good progress, I would say. So looking here, I think that this other one is going to be 4x4 from away from the board as well. Let me just eyeball it with my ruler. Yeah, that looks like 4x4 also, although it's actually not 4x4, I just realized, because there's a little lip here. Which is itself like 3 to 4 extra millimeters. I'm going to call it 3 extra millimeters for the lip. And that's on the X side of it. Yeah, so on the x-axis, we actually want to go in by 7 rather than 4. So we're just going to make that plus 7. And there we see it moves in a little bit. Okay, so this next one, it's going to be the same thing, but on the other end. So yeah, like that. And then there's going to be one in the middle. So how far do we go from the edge of the board to reach that? I'd say like 4.6 centimeters. .5 to 4.6. Let's say like 4.55. So 455 millimeters. I'm gonna guesstimate it to 455 millimeters from the edge of the board. So negative exp depth divided by 2 plus $455, right? Apparently not. Or no, it would be 45.5. Yeah, that's what I wanted. Looks right to me. Seems pretty good. Now, basically, we're going to take those three and repeat them a couple more times. But the next two are each going to be translated to the right a little bit. So let's start by copying what we've done here, making 2 copies. So now instead of +7, let's figure out how far to go over for this next pair. think I want those at like 315 millimeters. Let's give that a try here. Comment these ones out. Oh wait, wrong conversion again, 31.5 I mean. Yeah, okay, that looks good. I want to try to, you know, confirm that measurement with my calipers. Here, let me set this down. Okay, I've locked it in at around 31.5 millimeters. Now let me just compare that to my board here. Yeah, that looks pretty accurate, I'd say. It's hard to judge because, you know, I can't measure right to the edge of the board without eyeballing because they're, you know, they're stood up from the board and there's that lip. But yeah, I mean, from end to end, it seems about right. Just eyeballing it, I say that looks about right. So one useful metric is it's basically 31.5 is about the distance between end to end of these things. So what I'm talking about here, these guys right here, from like this side to this side is like, that's like 31.5 right there. And so, you know, if we measure how big one of these is, so let me zero this out again. So yeah, we're looking at around 7 millimeters for these. I was dead on 7 millimeters there for like the width of one of these metal bars. So, you know, if you say it's 31.5 between one end to the other end, then, you know, take off, you know, from like point to point, from the middle of one circle to the middle of the other circle, right? You'd go down by half of 7, and then you'd go up by half of 7 again on the other end, right? And those cancel, right? So, or they add to each other, which would be a total of 7. Yeah, so you need to, like, if you want to measure the distance between points, it would be 31.5 minus the 7 millimeters to account for, you know, half of the width on one end and half of the width on the other end, because the circles are in the center, right? So if I'm doing my math right, the distance between points should be 31.5 minus 7. Let's see if we can confirm that. So 31.5 minus 7 gives us 24.5. And if we look at our code here, so we have this one is at plus 31.5, and this one's at plus 7, right? So if we take the difference, that's going to be 31.5 minus 7, which is the exact calculation we just did there, which gives us a distance between points of 24.5. So it all checks out. Like the when we do the math, it all seems to check out as far as I can tell. So I think we've got that distance correct. You know, we'll see when we actually get our finished product and, you know, have it printed and sent to me. We'll see how good we did on our math. Hopefully it's right. I probably do not have time to do, you know, multiple iterations, so I'm really hoping I get it right the first time. But, you know, you do what you got to do. We will, you know, give it our best and see how it goes, and, you know, whatever happens, happens. So that was a pretty slick way to measure it, I think. We can do the same trick to get a nice measurement of the next set. So I'm going to measure, you know, top of this metal bar to bottom of this metal bar. And then we're going to do the same calculation to figure out point to point, right? And then translate that into how far the thing actually is. 45.25. Seems like 45.25. So I'm going to go with that. That seems like an accurate measurement. So that means the distance point to point should be 45.25 minus 7. Which is 38.25. And then the previous one was 31.5. So we're going to take that 38.25, right? And then we're going to say minus 31.5, 6.75. And then we're going to add that back to 31.5. So 31.5 plus 6.75 . 38.25. Okay, did I do that math right? I feel like I didn't do that math right because that's just canceling. But that's probably right. Or wait. So the distance I calculated is the distance between points. So no, I want, yeah, I don't want this minus in here. I just want it to be 31.5 plus the 45.25 minus 7. Right, because the 45.25 was from top to bottom, and then you take off 7 so that you get this the center of each circle, and then that's distance between points, and then we're saying we're going to add it to the last point to translate it down by that much. So 69.75 for the next set. There we go. And that looks correct. It should be, you know, a wider spacing than the other two. And you see that's exactly what we have there. So this is all looking good. It's all looking correct to me. So that's a major portion of it marked off. And then the other major portion is going to be the individual standoffs. And I think, so I've got it right now, I've got a standoff like here, but there's like a spot for one here and there isn't one. Maybe I want to put one there. I don't know. Maybe I took that off because the screw was getting in the way or something. I don't remember. Or maybe that's the one that I was... No, but the one that I'm using for the SSD is like that's from the Hi-5 Unleashed itself. So I don't think I messed with the standoffs on the Hi-5 Unleashed expansion board itself, so maybe we'll leave well enough alone. I don't think we're going to try to move the standoffs. So we'll just go with the ones we have placed as they are, I think. So there's 6 more of them to do. And I think this one over on this side is going to be a 4x7 again. So let me take a look. Yeah, that looks like 4. Maybe 4x4 actually. I think that one's just 4x4 because there's not a lip. It's not there's not a lip on that one, so I think it's just 4x4. Okay, and this is just going the other direction on the x-axis. So let's slot that one in. So that's going to be exp width divided by 2 minus 4, I think. And then negative exp depth divided by 2 plus 4. Yeah. Okay, perfect. 5 more to go. Did I put in too many? I think I maybe put in a few too many when I... Let me double check. Yeah, there's just 5 more to do. Oh, it's because I copied a bunch, right? 1, 2, 3, 4, 5. All of you guys can go. Yeah, okay. So for our next one here, I'll do this guy that's kind of in the like a little bit less in the x direction, but on the same location on the y-axis. So yeah, looks like about 60 something. Maybe like 63. Well, if I measure distance between it looks more like 64. But then we have to add I think I want to call it 63. So exp width divided by 2 minus 63, same depth. Yeah. Okay. So it's coming along pretty good, I'd say. Four more to go. Okay, this next one, I can measure it from relative to that other guy. So where did we say he was at? Those are the ones that were 69.75. I want to measure relative to that. So I want to measure point to point, but starting the one point at 69.75. So my ruler can't measure that too accurately. I might have to switch to the calipers. But if we're just eyeballing it here, I'd say we're around 87.5. Let me try to, double confirm that. So that's a rough measurement, but it's got to be around 17, 18, the distance between points. So a distance between points of around 17 or 18. Okay, I said 87.5, I think. Minus 69.75. 17.75. That's, I was saying it's like between 17 and 18, 17.75, 17 leaning to 18. That sounds like I'm in the right ballpark. So we're going to go with it. And I'm gonna have to end it here. So let me just finish this up quick. And thank you everybody, not for tuning in since it's not live, but thank you everybody for watching. You can catch me on Twitch at twitch.risky.tv when I stream, which isn't right now, someday in the future again. And you can watch all the episodes on the YouTube archive at risky.tv, and you can follow me at HMN_risky on Twitter to get updates about the series. I already did the Patreon shoutouts at the beginning of the video, but once again, that's patreon.risky.tv if you want to support the series. And with that said, thank you for watching and stay risky, everyone.